Hello everyone, myself Vinod. Today I came with a new topic, that is projection from moving frame. That's what I am writing here. Projection from moving frame. So as of now we have discussed different cases of projectile motion, that is from earth to earth, and from the top we can say horizontal motion, above horizontal and below horizontal we have seen. But today we will see the new concept, that is projection from a moving frame. So here also there are 4 cases are there, we will see one by one. So in that we have a case number 1, that is projecting a body in the direction of motion of a trolley. So this is case number 1. So what is that case? The projection of a body in the direction of motion of a trolley. That means the projection and the trolley here both are in the same direction. We'll see how it will be. So now here, so for that what I am doing is I am just considering one trolley here. Say this is my trolley. Okay, and this trolley is initially moving in this direction. So in this direction with a velocity v. Got it? So this trolley is initially moving in that direction, and say here one person is there and he is projecting a body with a velocity u, so that it is making an angle theta with the horizontal, right? So you already know from the resolution of vector concept, this component is my horizontal component and it becomes u cos theta, and this is my vertical component, it becomes what? U sin theta. We can also call it as ux and we can also call it as uy. This information you already know. So actually I have projected the body from the trolley. So we don't know what is the projection from the ground, we don't know. So we need to calculate what is the projection from the ground, right? So for that what I am doing is I am using relative velocity concept. So what is the projection of trolley with respect to what is the velocity of projection with respect to trolley here? We can write it as velocity of projection minus velocity of trolley, we can write, right? Velocity of projection with respect to trolley, I am projecting in the horizontal direction. Let me consider it is in horizontal direction. So x I am taking. If I take it is in the x direction, the velocity of projection in the horizontal direction will be what? U cos theta. So as it is I am writing here, this is u cos theta, which is equals to, we don't know what is the velocity of projection with respect to ground. So this is what? With respect to ground. So g I am taking here. So we don't know what is the velocity of projection with respect to ground, and minus what is the velocity of trolley with respect to ground, that is v, right? So I am taking it as v. So we have that information. From here we can calculate what? Velocity of projection from the ground we can calculate, and if I calculate it, value, it becomes what? U cos theta plus v. So this is what we have, the total velocity, that is the velocity of projection with respect to ground is u cos theta plus v, as the two bodies are acting in the same direction. So we have to use which component? The component of u cos theta is going to be now u cos theta plus v. We will see by using this we can find out different quantities. So for example, if I want to calculate horizontal range, so generally range formula is 2u that is 2ux into uy by g. This formula we know, right? That is 2u square sin 2 theta by g. We can also write like this, and this can also be write as 2 into ux is nothing but what? Generally u cos theta into uy is nothing but u sin theta by g. This is the basic formula that we know. But here u cos theta is going to be replaced with this value. Why? Because as these two are acting in the same direction, we have to consider it as a total horizontal velocity, horizontal component. Then my range formula becomes 2 into u cos theta becomes what? This value, u cos theta plus v into u sin theta by g. This is what my range formula. I hope you understand this particular point. And also, if I wanted to calculate the total time of flight, generally our time of flight formula is 2u sin theta by g. This can also written as 2 into u sin theta can be written as uy by g. You can see here, as it is acting in the horizontal direction, and uy is my vertical direction, right? So vertical component. So here there is no change in the vertical direction. So u sin theta will be remained constant, so that my time of flight will also be constant. It will never change. And if I see third example, for example, I want to calculate maximum height, which is equals to u square sin square theta by 2g. This we can also write as h is equals to u sin theta. We already know uy, and we can write it as uy whole square by 2g, right? So as it is a y component, there is no change in the y component. So what happens? The formula will be remained unchanged. So this is what the concept. Only horizontal component will changes, so that my range value is changed as this value. I hope you understand. We'll see the case number 2, so that will be very understandable. So case 2 is, case 2 we have is projecting a body in the direction opposite to direction of trolley. So this is what the case 2 here. So in this case, what happens? This is exactly opposite that of case 1. Now we'll see that. Now same situation I am taking. Say I have a trolley here. Say this is my trolley, and imagine this trolley is moving with a velocity v in that direction. Now in this case, the body is projecting opposite to the direction of movement of the trolley. That means he has to project this direction. Say this is u. So what happens? This component is u cos theta, and this component becomes u sin theta. This you already know, right? But here we don't know what is the projection from with respect to ground. We don't know, right? But we know the projection with respect to trolley is what? Minus u cos theta. Why we have to consider here minus u cos theta? Since as it is acting in the negative x direction, we have to consider it as minus. Now velocity of projection with respect to trolley can be written as velocity of projection with respect to ground minus velocity of projection with respect to trolley. Velocity of trolley with respect to ground, right? So this is also along x direction. That means what? There is no change in the y direction. That means vertical direction will not be changes. So now here, what is the velocity of projection with respect to trolley? That is u cos theta. As it is acting opposite of x, positive x, we can write it as minus u cos theta, which is equals to, we don't know this value, that is vpg, velocity of projection with respect to ground in the x direction, minus what is the velocity of trolley? That is v, right? So it will be as it is. And from here, velocity of projection with respect to ground in the x direction becomes minus u cos theta plus v. Only one change, that is we got here minus u cos theta, whereas in the case 1 we got plus u cos theta. Now we'll see how the change in the formulas. So first one is time of flight is 2uy by g, 2u sin theta by g. So as this is the vertical component, there is no change in the time of flight, right? And the second one, range, if you take, generally it is 2ux uy by g, but there is a change in the horizontal direction. That change is what? Minus u cos theta plus v. That means in the place of ux we have to replace what? Minus u cos theta plus v. Then the range becomes 2 into minus u cos theta plus v into uy by g. So this is what the range formula. And if I look at the third one, that is maximum height. So maximum height formula is what I would generally u square sin square theta by 2g. Here also it is depends on vertical component, but there is no change in the vertical component, it is as it is. So there is no change in the maximum height also. This is what the case 2. Now we will see case 3. Okay, now we will see case 3. So we have a case 3 here is, so as of now we have discussed horizontal motion, and now we will see vertical motion, that is up and down motion. Now here in this case 3 what is happening is, projecting is upwards, and trolley is also moving upwards. This is the case 3. So trolley is also moving upwards and the projection is also upwards. We will see how the situation. Now say this is my trolley again here, and imagine this trolley is moving with a velocity v upward direction, and also here one person is there, he is throwing a ball with a velocity u upward direction. Then horizontal component becomes what? U cos theta, and my vertical component becomes u sin theta, you already know, right? In this case also we supposed to calculate what is the projection with respect to ground, right? Now we have a formula, that is velocity of projection with respect to trolley. Here we have to consider y direction, y direction as it is moving upward direction, which is equals to velocity of projection with respect to ground along vertical direction minus velocity of trolley with respect to ground along y direction we supposed to calculate. So from this we have velocity of projection with respect to trolley is u sin theta, right? There is here we have to compare y component. So my y component is what? U sin theta. So that's what I am writing here, u sin theta is equals to, we don't know this value, right, minus what is the velocity of trolley with respect to ground, that is v. So I am considering this sign conventions, that is positive upward direction I have to take as positive, and positive x direction we have to take as positive. This is what the sign conventions. As now both are acting upward direction, this we have to consider as plus only, and then it becomes minus v. This minus as it is, right, and vtg becomes v, and then finally my v pg along y becomes u sin theta plus v. Understood this? This is what the projection with respect to ground in the vertical direction. Now in this case everything will changes. For example, if you look at the time of flight formula, that is 2u sin theta by g. This is the basic formula of time of flight, and you can see here it is depends upon the y component, but my u sin theta becomes what? This value, and then my time of flight becomes 2 into u sin theta becomes u sin theta plus v by g. This is what the time of flight formula. And also if I wanted to calculate maximum height, it is generally u square sin square theta by 2g, and this can be written as u sin theta value is this value is going to be replaced this, then it becomes u sin theta plus v whole square by 2g. This is what the maximum height formula. And if you look at horizontal range also, my range formula becomes 2ux into uy by g. Generally we have this basic formula, whereas ux is constant here, since we are projecting the body upward direction, horizontal remains constant, and if uy becomes what? U sin theta plus v, and my range formula becomes 2 into ux can be written as u cos theta into uy becomes this value, u sin theta plus v by g. This is what the range formula. And we'll see fourth case, that is final case. Now I hope you understand the case number 3, and we'll see case 4. If I look at the case number 4, body is projecting upwards, whereas my trolley is moving downward direction. This is opposite of what we have taken in the case 3. So in the before case both are acting upward direction, but here projecting is upwards and the trolley is coming downwards. And say this is my trolley here, and now here a person is there who is throwing a ball with a velocity u, and this becomes horizontal component, nothing but u cos theta, and this is u sin theta. Now this time the trolley is moving downward direction. So I already told you, when the trolley is moving downwards with the velocity v, we have to consider it as a negative. So we have to calculate what is the projection with respect to trolley is equals to velocity of projection with respect to ground minus velocity of trolley with respect to ground. This is also along y direction, because I have considered the motion in up and down motion, so we have to consider it as y, whereas horizontal component is remains unchanged. And what is this value? This value is as it is, that is u sin theta, which is equals to, what is the velocity of projection with respect to ground? We have to calculate in the y direction, minus velocity of trolley is acting downward direction, so we have to consider it as minus v. Got it? So why I took here minus v, as from the sign conventions this direction is positive and this direction is positive, as it is acting downward direction we have to consider it as minus v. And velocity of projection with respect to ground in the y direction becomes u sin theta minus v. This is what the formula we have. Now we will see the corresponding values of time of flight, maximum height and range. And then time of flight becomes, generally it is 2u sin theta by g, but here the time formula becomes what? U sin theta is going to be replaced this value, that is 2 into u sin theta minus v by g. This is what the time of flight formula. And case 2 is horizontal range, that is uy whole square by 2g, and h is equals to uy whole square is nothing but what? Uy whole square is nothing but this value, u sin theta minus v whole square by 2g. And third one is horizontal range, if I take, that is 2 ux uy by g, and r becomes 2 into ux will not change as it is, that is u cos theta, and my uy is going to be changed as u sin theta minus v by g. This is what the different formulas of this case 4. I hope you understand this particular concept. We will do one problem based on this, so that the concept is clear to you, right? Okay. Suppose the question is given like that: the velocity of projection with respect to car is I cap plus 2j cap plus 3k cap given, and the velocity of car is 4 meter per second west direction. Find range he is asking. What is the range he is asking? So this is what the question here. So generally he mentioned we need to find out what is the velocity of, find the range we need to calculate. First let me write the data which is given. Velocity of projection with respect to car can be written as velocity of projection with respect to ground minus velocity of car with respect to ground, right? We supposed to calculate this value, and we know this value. What is this? Car velocity of projection with respect to car is I plus 2j plus 3k, which is equals to, we don't know this value, minus velocity of car with respect to ground is 4 meters west. West is nothing but negative x-axis, so we have to consider it as minus 4i. Minus into minus plus 4i, when I bring it becomes minus 4i. So minus 4i plus I plus 3i is equals to velocity of projection with respect to ground, and it becomes 3i plus j, 3i plus 2j plus 3k. sorry, this is what, minus 4i plus I plus 2j plus 3k is equals to vpg, and it becomes minus 3i plus 2j plus 3k is equals to velocity of projection with respect to ground. So we got here velocity of projection. You already know here my ux is nothing but minus 3 and uy is nothing but 2. So range formula is generally 2ux uy by g, right? So r is equals to 2 into what is my ux value? Ux value is minus 3 and uy value is 2. J I am considering 10 now. It becomes minus 1.2 meters. So here we got the minus value, that means range value is acting in the west direction. I hope you understand this particular concept. This is what the projection from moving frame. Thank you so much.